Hi, I'm Holden. I'm going to talk about building recoverable pipelines with Apache Spark. This is really useful for people who have big data jobs which can fail in hour 23 or hour 24. This is really common with complex ETL migrations, which need to do some kind of roll-up summary statistics at the end. If this sounds like what you're doing, I hope you'll watch the rest of this video. And if not, I hope you'll watch it anyways. Thanks for watching. And if you're interested in these slides or code and all of the other things, this is the one link that you need. Of course, if you go there right now, it says coming soon because everything is done just in time. So I'll upload everything after this talk is finished. And yeah, okay, cool. I'll give it a second for the slower phones in the room to focus. Okay, cool. Clicky button. Yeah, so I'm Holden. My preferred pronouns are she or her, and I'm a developer advocate at Google. I mostly work on open source big data stuff. Most of what I do is Spark, but I also contribute to other projects. And I've been at a whole bunch of other companies, mostly working on open source code. And I'm a co-author of 2 books. One of the things which is a little different that I've started doing recently, which you may or may not be interested in, is I've been doing code review live streams. So if you're curious in seeing how large-scale projects with thousands of contributors do code reviews perhaps differently than you're used to doing inside your organization, you can come and watch them. I do them Friday mornings, and I also just do random little one-off ones when I end up stuck in an airport because I fly United. Yeah, all right. Cool. In addition to who I am professionally, I am trans, queer, Canadian in America on an H-1B work visa, which expires in 2020, which is just real fun, and part of the leather community. And this is not related to big data. There is no secret Canadian garbage collector we've been hiding from you. There is no secret Kubernetes oracle we've been hiding from you. But I think it's important and useful for us to think about what our communities look like. And if when we look around, everyone looks exactly like us, perhaps it's time to think if we can do something different in our community to make it more representative of the outside world. Otherwise, we'll just build the same tools that we had before, but with less GC overhead. And that's not really what I want to do in my life. I would much rather solve some new problems. Okay, so hopefully you're all nice people. You clearly all like databases of a certain kind. And occasionally you have big data jobs that fail. How many people have big data jobs that fail occasionally? How many? Okay, it's like 7 people. And for the rest of you, this is more of a place to hang out and chill while the other talk is going on. So that's fine. Okay, so we're going to explore what Spark is and why it's related, why I'm talking about it here. We'll talk about some of the ways Spark can fail in hour 23 of a 24-hour job. That's really great and a lot of fun. And we'll look at some of the things that we could do to make our Spark pipelines recoverable. It's really frustrating to fail in hour 23 and start it again. I'm no longer paid by the hour, I'm salary, so that really just doesn't do anything for me. That just makes my life harder. I don't get overtime. And we'll iterate on this a few times because there's a few different approaches that we can do to making recoverable pipelines, which all have some interesting sort of things that can go wrong with them, and hopefully in doing that, you'll get a better understanding of Spark. And then at the end, we'll talk about again, just in case you fell asleep in the middle. Okay, so what is Spark? It's a general purpose distributed system. For better or worse, it's built in the JVM. I'm sorry. That being said, even though it is built in the JVM, you can use it from non-JVM languages, including Python. And to respect everyone's sensibilities here, I will present the examples in Python. I don't want you to get flashbacks to your time with Java. It's one of the more active Apache projects, and it's faster than Hadoop MapReduce. And this is in part because Hadoop MapReduce set the bar really, really low in terms of performance. And that's really great. And so there's some things that we can do to make it faster, but they come at a non-trivial trade-off. And as probably most of you in the room are familiar with, this is the kind of technology that we use when our problems get too big for a single machine, right? If everything fits on a single machine, our life is happy, we can go and take coffee breaks, and our pager doesn't go off. But when we start having to shard everything, our life gets sad and full of whiskey. Okay, cool. So the different pieces of Spark. Spark has a whole bunch of different components. And in fact, many of the components we have 2 copies of. Yay! So we have 2 different machine learning libraries, because why provide one way to do things when you can provide 2? So we have an old deprecated one that works, and a new one which doesn't work yet, but it's not deprecated. Or, I mean, it sort of works. It has some rough edges. We have a graph processing system. It doesn't work super great compared to the rest of the components, but it's there. And we have 2 different streaming engines with, I think, 3 different streaming execution engines. They might have added a 4th, though. There was a new release earlier this week. More or less, every time someone gets bored, they just add a new streaming execution engine and then close all of the bugs as fixed. And then we reopen all the bugs because they weren't fixed. And yeah, I was sparkling them out. Also, we have a SQL engine, and I know that might not be the coolest thing to all of you, but occasionally you may find yourselves working with people who really, really love SQL, like a lot, and want to do SQL over a few different types of data sources, and you want to provide a unified view. And so Spark's SQL engine can be slapped on top of pretty much anything, and you can then have your analysts or whoever it is that needs to use SQL do it across all of your different data sets together. Okay, so people come to Spark because their MapReduce job takes longer than they think it will take to learn Spark. This is sometimes true. And the other reason they come is that it no longer fits on their MacBook Pro. And the solution to not having your data fit in memory on a MacBook Pro is clearly a distributed system. And sometimes they come to it because they have about 600 kilobytes of data, and they read in a trade journal that Spark is big data. And that's great. Okay, so it's big data, so it's clearly word count, right? That is what everyone uses. And this is actually a licensing requirement. All of the big data instructors have to put word count in their presentations, otherwise they take away our license. And that's why it's everywhere. And so this is a fairly simple looking piece of code. Ooh, that's a light. Okay, we read in some data. This data is in text files. It could be anywhere from kilobytes to terabytes. We tokenize it with spaces. Because I live in North America, I get to pretend space tokenizers are totally effective, except that one time I had to internationalize my code to Japan. We key everything by the word, and then for all of the things with the same key, we combine the values and we save the result out. And this is nice. It's great. We can count the words, and it's not that complicated. But it turns out that unfortunately, in the real world, people want to do more than just word count. It's very inconvenient. The samples just don't work quite as well. So ETL, keeping your databases in sync. Does anyone have Elasticsearch as a, yeah, okay. And so if you have Elasticsearch, you've had the wonderful experience perhaps of it losing data. And you may find yourself being like, ooh, you know what would be great? If we backfilled our Elasticsearch database periodically, because it's just gonna lose records. And the alternative is fixing Elasticsearch, but that's not gonna happen today. I need to do my job. SQL engines on top of non-SQL systems. What could go wrong? It's okay though. We can also do SQL engines on top of other SQL engines. Really exciting, questionable utility, but that's okay. We can do machine learning. Super important, very cool. We can predict if something is a cat or not, and that is the state of the art. Deep learning, though, venture capitalists aren't really interested in machine learning anymore, so we added another scheduler to it because that fixes everything, and then we called it a deep learning system. And so now you can schedule your TensorFlow jobs on top of Spark, on top of your SQL system, on top of the stack gets really, really deep. But hopefully it doesn't crash, and that's great. And we're just going to look at simple cases because they fit on slides, but the techniques that we talk about, we can plug into any of these kinds of use cases. Okay, cool. So does anyone remember the Ford Pinto? Okay, so for those of you who remember the Ford Pinto, this is called foreshadowing. And for the rest of you, this is just a silly picture with a car. Okay, Spark is going to fail though, and it's going to fail late for a few different reasons. Lazy evaluation is really, really cool, but it means that even in our word count example, if our input files didn't exist, or our HDFS connection was improperly configured, or if we were querying a database and we didn't have permissions, we wouldn't get the error until we tried to save the results out. And so that's cool. Okay. Out of memory errors, so much fun, so unpredictable. Errors in our own code. I mean, I write a lot of errors in my code, and there's this thing where like you change just one small piece and everything runs, it's fine, and you're just like, you know what, let's just deploy this to production. I only changed one thing, and then everything fails. The data size is increasing without the required tuning changes. And so as your database starts to grow, you may need to add more nodes to Spark. If you don't add those nodes to Spark, it will try really hard to finish your job, and then like 23 hours later, it will fail. And the other one is we do a kind of bad job of type checking. And probably people in this room understand the joys of key skew, and that can also make everything go boom. Okay, great. Okay, so now our Ford Pinto is on fire, yeah, it's not good. Okay, but let's assume that our Ford Pinto, or Spark in this case, is eventually going to catch on fire. What we want to do is we want to make it so that we can put the fire out and get our Ford Pinto back on the road quickly. So why can't we do that? So one of the things is that Spark jobs tend to be scheduled on top of a cluster like Kubernetes or Yarn, and when they fail, all of the resources go away. We just give them back to the cluster manager, and we say, we failed, I'm sorry. For some people who use notebooks and like persistent clusters like Livy, that's not quite the case, and you can have your Spark context and your cluster resources still hanging around, and you can recover a little bit easier, but there's some downsides too. Okay, so our first take at making a recoverable word count is, and I'm sorry, the JVM did show up anyways. It's the party monster. It comes and joins me everywhere I go. What we do is we say, hey, if this file exists, just load it. Otherwise, oh, oops, fuck, I screwed this line up. Anyways, that should say like save. Oh wait, no, this is right. Okay, sorry, it's been a long day. So if the file exists, we're gonna just load it, and then we won't compute our word count. Otherwise, what we'll do is we'll return sort of the raw computation, right? And so the idea here is we allow ourselves to have a place to checkpoint it, and if things go wrong, we'll just run our code again and return to that checkpoint. So that's okay. The problem is, though, if our job fails in a kind of weird way, the files will exist, but they'll be in a bad state. So we need to check to make sure that things are actually in an okay state. And the other one is, if our entire job succeeded, right, we have all of these sort of temporary recovery points that we haven't cleaned up, right? And they're just sitting in our persistent storage, and that's not great. And the other one is that it's not async, right? We're just gonna block when we're doing our saving, and we could do something smarter there. We could also use functions so that we have general purpose code. So what about if we did this a little bit differently? So we can check and see if the success marker that Spark leaves exists. That's pretty similar. And continue with this previous code. But we can still do better than this, right? We don't clean up on success. It turns out cleaning up on success is really annoying and doesn't fit on a slide. And we have to wait to finish writing out our files. It's going to slow our pipeline down to make it recoverable. And presumably the reason we wanted to make our pipeline recoverable is that it was kind of slow to begin with, so we don't want to make it slower. Or we want to minimize the impact of making it recoverable. So what we can do is instead, oh wait, this is just using the function. It's still not async. Here we check for the 2 different kinds of success files. We take in data frames, and we check that the success exists. If they do, we load it, and we return that we're reusing it. Otherwise, we save it and return the default data frame. And for those of you who do Spark, you may realize that there's some sad problems with this solution. Clicky button. OK, so we can try and not slow down the happy path. We can make the happy path async. And we can clean up on success. Damn it, I meant to do that earlier, but that's OK. So what would we do to make the saving async? Instead of calling save, we use this non-blocking data frame save, where we kick off a thread and we save it back there. And that's kind of not great. If we were working in the JVM, we have proper async methods, but we don't, so we can just use Python threads here and kick off our save. But this is going to actually break a lot of things, and now we get to see some of the internals of Spark to understand why making this code async doesn't just solve this for us. So let's take a look about what's going to explode. So at Spark's core, everything that we ask it to do, it doesn't bother doing until we finally force it to do this. And it constructs what's called the directed acyclic graph, also known as a fancy name so that you can write papers about it. And most of our work is done by these transformations, and when we call these transformations, Spark doesn't do them, right? All it does is make a note that it needs to do it. The problem is that the data doesn't really exist until it absolutely has to. So even though it looks like we're saving a thing that exists, and that should clearly be fine, and then we're going to go use that thing just right after it, it didn't exist until we called save, and it's going to go away right after we call save again. And that's unfortunate, right? We're going to have to make it exist twice, and even if we make it exist twice, there's going to be a slight problem. Here's like the standard diagram. You can see that the directed acyclic graph, it's not a very complicated one here. It's all just straight lines. But we could have multiple pieces coming together or different things like this. And we can see stage boundaries exist, and there's some weird things. And if we use data frames, we get a thing called a query plan, which you can think of as pretty much the same thing, but more difficult to read. And it has things like code generation and stuff like that inside of it. So what about if we do this? What's going to go boom? So we cache it, and then we call count, and then we do a non-blocking data frame save, and then we return the data frame. And this sort of fixes our problem to a degree, right? If we have 2 different things ask Spark for the same piece of data, Spark isn't smart enough to realize that 2 different people want the same thing, so it just computes it twice. And that's OK, but if you're like processing, you probably are doing your recoverable part on your expensive part of your pipeline, and so doing the expensive part of your pipeline twice is really, that's fine for me. I work at a cloud company. We sell you compute resources, but that might not be fine to your boss. And so by forcing this cache and count, what we do is we tell Spark we want to use the data twice. It should make it exist in memory and keep it around, and then it should save it, and then we'll return the result. And we're not going to block on the save because the data for sure already exists, and the save can just read out of memory, right? We don't have to worry about the fact that we're going to ask it for a second time. It'll just go back and read that same block of memory. And the fact that we're reading that same memory to write out is totally fine. We don't have an expensive operation happening twice. We have an inexpensive operation happening twice. And so this is great. Everything works, kind of, or well enough, right? It's not ideal. There's some minor downsides to it. But we now have a recoverable pipeline. Yay! And you probably shouldn't put this everywhere, right? If you're doing word count, for example, you don't need a recoverable pipeline most likely. But if you have like really complicated business logic, if you have something which is hitting an expensive API server, if you have something which is taking a really long time, and after that you have a job which is occasionally failing, making it so that Spark can recover from that point is really useful. Don't make everything recoverable, just do it on the parts that matter. So that was fun, right? We can replace our word count with our backfill operations and all of the expensive data enrichment things we need to do. You still need to clean up the files. That'll just be in the version on GitHub. It doesn't fit on a page, unfortunately. And the other problem is you also need some concept of job IDs. Spark has a built-in understanding of what a job ID is, but you probably want to use your own so that you can control it. If you want to, like, for example, run 2 different backfills, you don't want them like recovering from each other part of the way through. You want them to run separately, and so you need to give them different job IDs so they don't stomp on each other's data. Okay. So if you're interested in Spark, there's this really nice Apache Spark YouTube channel. I have a large collection of Spark videos. Most of them are okay. They're all on YouTube. This training is from 2014. It's really old. If you look for it, though, it's still pretty solid, and it's one of the free ones that you can get. If you're less constrained by money, you can give O'Reilly money, and you can buy Paco's wonderful Introduction to Apache Spark video series. And they also have other video series from other folks if you have money. They're a lot nicer produced. They edit out the parts where we swear, and when like we screw up, they just go like, okay, we'll take number 2, as opposed to just being like, well, fuck it. Okay, cool. There's a large collection of Spark books. I am a co-author of many of these, but not all. If you have coworkers who are really into Python, or you're really into Python, Learning PySpark by Thomas and Denny Lee is a really amazing book. I owe Denny several beers for reviewing some of my work, but I think that his book is really quite good. Learning Spark is one of the Spark books I co-authored. I think it's pretty good. It's a little out of date, to be fair, but I still think it's pretty good. Fast Data Processing with Spark is the very first Spark book written, and boy, does it show. I would not buy that book. I wrote it. Please don't buy it. It will be a waste of your money, and you will hate me. And High Performance Spark is my latest book, and we'll talk about that in just a second. Oh, and the other books are by other people who are lovely folk, but I don't owe them alcohol or make money on it, so it's less important. So I have a book. It is the gift of the season. The season is called Still Being Alive. It's very exciting. It's more or less unrelated to this talk. It's about Spark, but it's very much focused on just trying to make things go faster. It's not really about building recoverable pipelines. And if you have a corporate credit card, it's a really great gift to buy many copies of. Cats love it. This is also the book where I realized you can negotiate royalties with publishers, and so I got a much better deal on this one. It is a terrible introduction to Spark, but this is still the book you should buy. Just make sure that you don't return it, because then they take that out of my royalties.